those. All right, Abby, we're just going to take a couple minutes going over those, looking at those answers.
Go ahead. Do you know when we send the anatomy kits down? At 8:30. Thank you.
All right, as you're going through these, let me know if any of them aren't matching what you're getting. All right, do we need to talk about any of those? Amber.
On the page, that is surface areas of heads and cones, number 3.
This one with the 8 and the 12?
Yeah.
Okay. All right, so to do this one, you needed to drop the height because we need the height to find. Do we need the height to find surface area? No, because the formula is 1/2 times perimeter times slant height. So our perimeter here is diameter times pi, so it's 8 pi for the perimeter. And then slant height is 12. So that's how I got that 48 pi. And then directions all said round to the nearest whole number. So I took 48 times pi and rounded it to 151. And yeah, Alyssa.
Number 2 on page 9.
Okay, number 2 on page 9. This hexagon one?
Yeah.
All right. To find volume of a pyramid, it's going to be 1/3 times the area of the base times the height. So if we do area of the base first, for a hexagon, if you remember, that's 1/2 times apothem times perimeter. You guys see with that glare? We're going to close the window. Okay, nobody's complaining. So our apothem is 5.5. The perimeter is 42 because it's 7 6 times. So 1/2 times 42 times 5.5 is 115.5. So that's my area of the base. Times that by 1/3. And then multiply it by the height, which is not currently listed. So the 10 goes here. And this is like a cutout of this triangle right here. The 5.5 is in the same position on this other side. So it is also an apothem. Every line from the center out to the middle of this hexagon is the same length. So we only need to find the one side. You'll do Pythagorean theorem for that. So it'll be 5.5 squared plus something squared equals 10 squared. If you work that out, you get 8.35. So depending where you're rounding off, whether you're rounding to tenths or hundredths, your answer will be slightly different than mine. So that is our height of our pyramid. So we'll multiply all that. 115.5 times 8.35 times 1/3. I got 321.475 on my calculator. Now, I didn't include any units on this because I was doing it in a hurry, but yours is going to have units. This one is volume, so it's going to be centimeters cubed. All right, any others, guys? Amber.
I think we were looking at the wrong one.
Uh-oh.
The surface area of the pyramids and cones. It's hard to describe. It's on this page next to this one.
Okay. Page 6. Yeah, got it. Surface area. So what did we do up here? We did lateral area only. Okay. So we need this one. The one that's on page 6 asks for surface area. The one that I did before was lateral area. So if you noticed, it's the exact same cone that we just did. So the lateral area is 48 pi. And remember, that's 1/2 times perimeter times slant height. And then to add the surface area, we're just going to add the area of the base. That's its lateral area plus base. Our base is a circle with radius 4, so it's pi r squared. I'm going to do 48 plus 16. Oh yeah, I got the wrong answer. So it's supposed to be 64 pi, not 112 pi. And that rounded off is 201. Listen.
Number 4 on that page.
Yep. Number 4. So you didn't include the slant height, but I know it's 5 because I'm making a 3, 4, 5 right triangle. If you do that with Pythagorean theorem, you do 9 plus 16 is 25. So that's how I got the 5. So my lateral area for a pointy figure is 1/2 times perimeter times slant height. Perimeter is going to be 2 times the radius times pi, so that's 6 pi. Slant height is 5. So my lateral area is 15 pi. Add in the area of the base, pi r squared. So that's 9 pi. And then those two added together, lateral area plus base, is how I got the 24 pi. Cool.
Well, do we change that to like look at time?
The direction, yeah, the direction said write your answer as the nearest whole number. So yeah, so that's how I got this. Go ahead and change it to the 75. Because 24 times pi is close to 75. And then it'll be inches squared because it's area. Hey, Amber.
If we don't have the whole number, we don't get it wrong.
No. Richie. Absolutely. Number 6 on page 4. I'll unfreeze it when I'm done scrolling so don't make you sick. Okay, 6 on page 4, this triangular prism looking one. Okay. We are finding surface area. So first do the lateral area. So it's perimeter times height, because this one is not coming to a point. So when you unfold it, these are just rectangles for the lateral area. Perimeter is 3 plus 4 plus 5. So that's 12. And the height is 8. All right, when I'm talking perimeter, I'm talking perimeter of the base, which in this case is the triangle. So our lateral area is 20. And then we're going to add the area of each of the two bases. It's a right triangle, so we're just going to do base times height times a half. So 1/2 times 3 times 4 is 6. How did I get 108? There's 2 of those. So 6 plus 20 plus 6 is 32. I must have been doing volume in my head. The answer is supposed to be 32 inches squared. Cooper. Because I added. Nobody stopped me. Sorry. It's not 12 times plus 8. It's 12 times 8. You guys didn't catch me there. It's not 20. It is how much? Oh, just 96, not 196. So I was right with 108. So it's 96 plus 6 plus 6. Okay. Ooh. Amber.
Can we get the last two on the last page?
Last two on the last page. Absolutely. Oh, these are fun. All right, I'm going to type these because there's a lot of numbers. All right, so we're trying to find the volume of a sphere whose surface area is this. So we're going to start with the surface area equation, which is 4 times pi times radius squared. Right, 4 pi r squared. And then I'm going to work that out to solve it for r. So first I'm going to divide both sides by 4 and pi. So 101.34 divided by pi, and then divide that by 4. What? And you get about 8. So I have 8 equals r squared. Then I'm going to square root that. And I get 2.83-ish. So that is the r that I'm going to need in the volume formula. So then I take volume equals 4/3 pi r cubed. And I'm going to put in that 2.83 in for r and work that all out. So 2.83 cubed first, then times, you could leave the pi off, but I didn't. Then times pi, then times 4, then divided by 3. And that's, well, this time I got 94.9 instead of 95.9. It's all about the rounding. So pretty much anytime you get a working backwards problem like this, you want to solve it for r. And then you can go back and do whatever they want you to do with r. Okay. Number 8 is kind of the same. This time we know the volume, so volume equals 4/3 pi, multiplication sign in there, r cubed, and I'm going to solve that for r. So I'm going to divide, that's what I actually did. I divided both sides by 4, I multiplied both sides by 3, and I divided by both sides by pi. The divide by 4 and the multiply by 3 is the inverse of the times 4/3, which is times 4 divided by 3. Divided by 4 times 3 divided by pi. So that I got 220.5 approximately. and that is equal to my r cubed. So then I need to take the cube root. And we talked about how to do that the other day, and you get about 6. So your r equals 6. Then you're going to plug that into the surface area equation, which is 4 pi r squared, and put the 6 in there and work that out. And I just left the pi at the end this time because it was a nice number. Okay, any others? Yes, millimeters cubed. No, millimeters squared because we converted it to surface area. Okay. So that's that. Let's take a look at Friday's CSI thing. Okay, where did it go? For those of you who worked through them all and then added them up at the end and didn't get the right answer, I want to let you know where you went wrong. Ella?
I had a question on the other one, please.
Okay.
Number 2 on page 7.
This guy?
Yeah.
Okay, find the volume. So it's a prism. Volume is just area of the base times the height. That 2 goes up there, and the 5 can be down here. So I'm finding the area of this triangle. It's just easier to look at the top on this one than it is the bottom, but they're the same. It's the area of the triangle. It's 5 times 2 times a half, so it's just 5. That's the area of the base. The height is this guy right here. So then it just becomes 5 times 8 as your volume. So it'll be 40 inches cubed. Oh, I put the 5 in the wrong spot. It goes on the back because it's right angle there. We didn't need to know the hypotenuse on this one, which was nice. Okay. All right. For our CSI thing, I'm just going to briefly give you the answers to each slide. And those of you who did it will be either reassured or angry, and those of you who only got through half will be reassured or angry on those ones. Okay. The Rock of Gibraltar, the answer was 96. The 2 pyramids, you were supposed to subtract their volumes. The answer was 9,401. Right here in this box. But then you don't deal with it till the end. Puzzle 3. I think a lot of us forgot or didn't notice that we had multiples of some of these pieces. There were 6 columns, 2 bases. The volume was 4,873. For the cannonballs, this one was a fun one. You can't stack cannonballs so close together that you don't have any air gaps like you could stack boxes. So you can only pack that closet 63% of the way full. So after you figured out how much closet space you really could use, and you divide it by the volume of each cannonball, you can get 89 of them in that closet. All right, for the Pentagonal Prism, the answer was 2,665. Yep. So this box would have been, symbol will be equal to, so yeah. I would have put a pentagon in this box, not that you can. Like something like that. You just have to remember that the pentagon was equal to the 2,665. So honestly, if you didn't get the answer in the slide, but maybe you wrote it on the notes down at the bottom, like Pentagonal Prism 2,665, that's fine. The box is not big enough. The cake one is probably my favorite slide. The answer is the 367. But if you notice, there's a super easy way to do this. You had to find the lateral area of each of the three shapes, because we were going to frost the vertical sides of all three shapes. But then the tops, you didn't have to figure them out individually. You just had to figure out the one rectangle. Since I didn't frost underneath the triangle, I just did the triangle once, the circle once, and the rectangle once. So really, that's just the area of the rectangle. 367. So then you take those numbers and you put them into this equation to find your actual suspect. And that I won't tell you the answer to. Cool. 9,401. Later.
So when it says like body square, are we calling that number by body?
Uh-huh. Yep. Okay. We have, how much time left? 10 minutes. I want to talk about the AV2. This was the quiz you took a week or so ago. This is the same one. But just a reminder of how to do these. It's been a little bit. All right, polygons are similar. Find the scale factor from the left to the right. The scale factor is the number that you multiply the first shape by to get the second shape. So pick a corresponding set of sides, like 12 and 6. So 12 times whatever the scale factor is equals 6. So solve that for S. Scale factor in this case is going to be a half. The shape got smaller, not bigger. A lot of us put 2's there. Well, the 6 times 2 is 12. But you got to go in the right direction. Left to right. So then the same thing for number 2, but make sure you're picking corresponding sides. I would do 18 and 24, but you could do 15 and 20, but don't do 15 and 24. They don't go together. So 18 times something equals 24. 24 divided by 18 is 1.3 repeating, and as a fraction, 4/3. So my scale factor in this case is 4/3. I would take 1.3 repeating also. The shape got bigger. That's why the scale factor there is larger than 1. Okay, and then we talked about ratios of perimeters, ratio of sides, and ratio of areas. Ratios of sides and ratios of perimeters were the same. And remember, they were related to the scale factor because they're flipped upside down. So the ratio of the sides in this example, number 3, is 8 to 12. Simplify that. 2 to 3. Ratio of sides and ratio of perimeters are the same. So 2:3 is the answer there. That is the ratio of the perimeters. I didn't have to add up and find the actual perimeter of the shape. I just had to pick 2 corresponding sides and simplify their ratio. On number 4, pick 2 sides that go together. Either do 7 and 14 or 3 and 6. Ratio of their sides. Simplified. That's the ratio of their perimeters. My goodness, the emails this morning. All right. Ratio of areas is like ratio of perimeters, except we have to square them. So start with ratio of sides. Be careful that you're picking corresponding sides. 48 and 40. So I'll start with that, and then I'll simplify it. Both of these divide by 8. So 6 and 5. Ooh, hello. That's the ratio of the sides, or the ratio of the perimeters. But we want the ratio of the areas. So I need to square those numbers and learn how to type. 3625 is the answer for that one. Okay, stay with 6. Take 2 corresponding sides, simplify them, and then square them. Notice that and a lot of people got these 2 backwards. The smaller shape goes with the smaller number. It was first. The larger shape goes with the larger number. It was second. Scale factor is the one that's backwards in our head, not ratios. Okay, big to small. For the next couple, you use the ratios to find the missing perimeter. You don't actually have to calculate and add up the perimeters. The ratio of our sides is 3 to 18, which if I simplify that is 1 to 6. That means the ratio of my perimeters also needs to be 1 to 6. So here is where we do cross multiplication. The ratio is supposed to be 1 to 6. I know the small one is 10. Trying to find the large one. So I get a perimeter of 60. Okay, on this side, I'm making sure I'm picking corresponding sides. 18 to 24. That simplifies to 3 to 4. So ratio is 3 to 4. I don't know the little one. Yes, I do. I don't know the big one. I didn't list the little one for you, but you have all the sides. So it's 18 plus 21 plus 24 plus 9, 72. And then you cross multiply that to get the perimeter of the big guy. Okay, any questions on those? Good. Cool. Yeah, go ahead. All right, this one, we're doing the area. It gets a little harder. Same kind of setup though. Find the ratio of the areas. So if we start with the ratio of the sides, simplify that, divide it by 4. Then don't forget to square it because we want ratio of areas. So it's 25 over 9 equals 540 over a question mark. Okay, we still got 5 minutes. You guys are packing up on me. And in here, 5 to 6 is the original ratio, not 5 to 6, 5 to 30, 1 to 6. Square that because we're looking at areas. So 1 over 36 equals question mark over, goodness gracious, 504. And then you solve that. Okay, I know you wanted me to get to sectors and segments. So let's do 14. Sector is just a large slice of pizza, in this case more than half of a pizza, but you take the part times the area. So the part of my sector is 255 over 360, and then times that by the area of the whole thing, by pi r squared. So then this answer will be less than the area of the whole thing. Okay, that's your sector. Part times area of the circle. You could try to reduce that and get a fancy fraction. Over here, it's 1/8. There's exactly 8 slices that big, but that's not helpful for this big one because there's not more than one of those. So just do angle measure over 360. Okay. And then segment starts that way. It starts with finding the area of the sector times pi r squared. So we have the area of this sector is 15 squared times 60 divided by 360, 37.5 pi. But then we need to find the area of the triangle and subtract them. All right. Those two sides are 15, and this just happened to be a equilateral triangle, so it made this side 15. But you have to drop the height, split the angle, then use trig to find that height, that red height. This being a 30, 60, 90 triangle, that height is going to be, oh shoot. X root 3, 2x. 15 is the 2x. 7.5. So this middle height is 7.5 root 3. Nah, you can't even read that. The height is 7.5 root 3. So I'm going to take 7.5 root 3 times 15 times a half because it's a triangle. And then I'm going to subtract those two values. That's how you get the area of the segment. Okay. So the hardest part still is finding the area of that triangle. Do your best on that. Okay, questions at home or questions in here? That was a lot today. Quizzes tomorrow. Go ahead and join the meet again tomorrow, guys. I know you don't usually do it that way, but I'm going to switch it up. Join the meet. We'll do the quiz. And then I'll see you guys tomorrow.